Okay, so we are solving problem number 5 from chapter 4 of Giancoli 6th edition. So the first problem is we have just one box that has mass m1. So I'm going to put here the box with mass m1, and it's on top of a table, so it's touching this table. Okay, and the first question is what is the weight of the box and what is the normal force act on it because it's touching the table. Okay, so we are going to draw all the forces that we can think of on acting on that box. So the first force is the one caused by gravity, is the weight. So every object on Earth has this force. I'll call it Fg, it's the force from gravity, and it's equal to mg. M in this case is m1 multiplied by g, always pointing down. Now this box is touching the table, so it's touch the table, it exerts a force on this table. Okay, the table reacts and exerts the same force opposite direction on that box, and this is the normal force. It's the force of touch, of contact, and it's a force that is always perpendicular to the surface. Okay, so I drew all the forces, and now I'm going to use Newton's second law to try to get the values of these forces. Okay, so according to Newton's second law, I sum all of the forces. Let me use a reference frame to guide me writing the signs of this force. So I'll say that whatever points up is positive. Okay, so I have Fn is positive minus the force caused by gravity minus the weight, so minus mg, m1g. Now this object is completely at rest, it has no acceleration, so sum of all the forces equals to ma. Since a is 0, this is going to be equal to 0. Okay, so from this equation I know that the normal force has the same magnitude as the weight of the object. I can find the weight of the object is just m1 multiplied by g, pointing down, and with that I can now find Fn, which will have the same magnitude but will be pointing up. So this is the part A of the problem. Now let's go to part B. What happens in part B is I still have that box m1 touching the table, but on top of this box we put another one of mass m2, which will be touching box m1. Okay, again we are going to draw all of the forces in each one of the boxes to try to solve the problems. What are the questions of the problem? First, it wants to know what is the normal force that the table exerts on box m1. Okay, so we want to know what is the normal force that the table exerts on box m1. Okay, and the other question is what is the normal force, okay, the normal force that the box 1 exerts on box 2. Okay, so the normal force on box 2. So I'll call it normal force on box that has mass m2. Okay, so these are the two questions. To solve this problem, again, let's draw all the forces on each one of these objects. So starting with m1, we have the weight m1g. It's touching the table, so it has the normal force, it has this contact with the table, so I have here Fn caused by the table. Okay, what else? Well, I have this box m2 touching the box m1, so exerting a force down on this box 1. Okay, all right, so I drew all the forces on box 1. Let's move to box 2. Okay, so box 2 exerts this force Fn box that I'm calling on box m1. Box m1 reacts, exerts the same force, same magnitude, but opposite direction. Okay, what else do we have in box m2? Well, the weight of this box, which is m2g. Okay, so I drew all the forces. Now I go for the equations of each box individually, independently. Okay, so let me write all the forces in box 2. So I'm going to write here box 2. What are all the forces there? Again, let me choose a frame, and I'm choosing that positive up is positive. So for box 2, I have that normal force caused by box 1, okay, minus the weight of box 2. Since box 2 is completely at rest, this is 0. Okay? Just by looking at this equation, I already know what is the value of the normal force caused by box 1 on box 2. And so this, which was one of the questions, is just equal to m2g. Okay, now let me write the equation, Newton's equation for box 1. Okay, so on box 1, what are the forces that we have? We have Fn caused by the table, so it's the reaction from the table on box M1 pointing up, and the other forces are pointing down. So I have minus M1g, which is the weight of this box, and I also have minus Fn box, which is the force caused by box 2 on box 1. Box 1 is completely at rest, so this is 0. Okay? Now you see that from this equation I can find the value of the normal force caused by the table. Because I already solved above, I found this, the magnitude of the contact, the force of contact between the boxes. So now I can find the force of contact between the box 1 and box and the table. Okay, so this is the